Hello, and welcome to another conversation with myself, Mark Vernon, and Rupert Sheldrake. Hi there, Rupert.
Hello, Mark.
Today, we thought we might talk about matter, this basic stuff that everyone presumes they know what they mean when they refer to it, seems somehow fundamental to our worldview. But Rupert, this notion has a history, which we'll no doubt get to, but I wonder whether it might be first worth beginning with what actually in science is meant by matter, because it may or may not be so obvious.
Well, the ideas have changed, of course, as you say, with the history. What's meant by matter now is a kind of process. Um, David Bohm, the physicist, once said that matter is frozen light. And instead of the idea of matter as being made up of little atoms like billiard balls, just hard, impenetrable stuff, which was the 19th century view of matter, indeed, a much more ancient view of matter, we now have the idea of matter as vibratory processes. So a proton, a nucleus of an atom is made up of vibratory particles, protons and neutrons. They themselves are as particles, as de Broglie showed at the beginning of the quantum revolution in the 1920s, that these material particles, subatomic particles, are actually vibratory processes. And the electrons around the nucleus are standing waves of vibration. They're waves in matter fields. In quantum theory, the idea is that matter is vibratory patterns in matter fields. And so when David Bohm said matter's frozen light, it was really taking the view that light is by definition on the move, and it moves at the speed of light, but the energy of light can be trapped in matter, and as soon as it's trapped in matter, it's bound in a particular place, and it sort of goes round and round and round. In the case of electrons, instead of streaking off at the speed of light, it's trapped in an orbital, and it's localized. So then, according to these views, you see matter is then localized in a particular place, or a particular state of motion with momentum moving along. And its localization has two aspects which are related to its mass. And mass is, of course, the quantitative measure of the quantity of matter. 10 times greater mass means 10 times more matter. And most of the mass in an electron, in an atom or a molecule is in the nuclei. Only a small part is in the electrons. So the mass has two aspects. One's usually called inertial mass, which is what binds it to a particular place or particular state of motion. It means that it basically stays where it is. And the interesting thing, according to the de Broglie equation, Broglie, Broglie, the French quantum physicist, according to the de Broglie equation, the frequency of vibration is proportional to the mass involved. So if it's twice as heavy, it vibrates twice as fast, roughly speaking. So the frequency, the faster it vibrates, the more it's tied to a place, the more its inertial mass is, the greater it is. Now, the other aspect of mass is its gravitational effect. And gravitation links all matter in the universe, as Newton showed, to all other matter. All matter is interconnected through gravitation. Every particle of matter attracts every other particle of matter in the universe. That means that in some sense it has to know where it is and how much of it is there out there. If a meteorite is rocketing through space and comes near to the Earth, and it's attracted to the Earth through the Earth's gravitational field, it has to sense the direction of the Earth and also sense that there's more Earth than there is meteorites, so there's a greater gravitational pull. So there's an interconnectedness through mass. So far from just being brute, unconscious stuff that's just pushed around like billiard balls, matter is a process that's rather mysteriously tied to place. And the whole fuss about the Higgs boson in modern particle physics was that the Higgs boson is supposed to be a particle that links massive objects like atomic nuclei to an underlying field, the Higgs field, which sort of glues them to their place. And it's supposed to explain inertial mass. So it's much, much more mysterious than just little billiard balls trundling around. It's mysteriously linked to place. It's the speed of vibration of the matter is an index of how much is linked to its place, and it's intimately interconnected throughout the whole universe. And that's, of course, just the basic building blocks of matter, the atoms and the subatomic particles. Then, of course, they can be assembled into molecules, crystals, and all sorts of forms.
I mean, it's already very fascinating what you're saying there because it's so counterintuitive to the everyday experience and worldview that assumes matter is kind of hard stuff that is in a particular place. It's not anything like congealed light, and I suppose that our unthinking common sense assumption confirms that. If I to quote, Dr. Johnson, if I kick a stone, it hurts. And so are we talking about the description of matter with the de Broglie equation and so on at the quantum scale in a way that is so beyond the everyday scale that the everyday sort of assumption that mass is hard stuff still works perfectly well? Or to put it a bit more sort of provocatively, the idea of mass as congealed or sort of static, contained, trapped energy, I can imagine that that might have a kind of new age appeal, as if you can work with mass somehow and shift energies or um, give it some sort of sense of spirit that might be misusing the science because the science describes mass in at a level that is just way beyond everyday experience. How does what you're saying relate to the sort of brute idea of mass, which I agree is actually a rather rarefied notion in the 19th century, that it's particles whizzing around. I mean, incidentally, I think even in the ancient world, when there was such a notion of atoms, it wasn't really like modern day mass. The Epicureans, for example, they talked about soul atoms as much as grosser atoms they tended to refer to, and meant something different, I think, therefore. But maybe we should come back to that. But yeah, just this question of, so what about our everyday assumptions? Are they just wrong? Should we be experiencing the world differently?
Part of the everyday assumption means that when we think about matter, we think of solid matter, like kicking a rock or something, or tables or chairs, but solid matter, of course, it's been known since the ancient world, is only one state of matter. There's the liquid phase of matter, as in water, flowing in rivers and the sea, where, of course, it's much more flexible in the way that it behaves. And then the gaseous state of matter, like steam or air, where you can't kick it and it's not solid. I mean, people have always known that water could be ice and it could be water and it can be steam. The solid, the liquid, and the gaseous phases. And so matter in its gaseous phase is much more tenuous, and even more tenuous than a gas is a plasma, where you have charged particles. A lot of space is filled with dilute plasma, which can conduct electricity and isn't at all like solid matter as we usually think of it. So I think even the ancient view of earth, air, fire, and water, where fire is, in a sense, a stand-in for plasma, because a flame is a plasma structure, has always informed people's thinking about matter. It has all these aspects. So the gaseous phase is definitely more tenuous. And of course, in the 19th century, they thought there was an even more subtle form of matter called the ether, which was supposed to be the medium through which light was carried, the luminiferous ether. Now, modern physics says, well, we don't need that concept. We'll just have fields that carry light. Now, fields are somewhat different from matter but they're intrinsic to matter as well, because an electron is a vibration in an electron field, and a proton a vibration in a proton field. So the fields are what give form or structure to matter. And I think one part where I think we may connect with the history through modern science, I see what you think about this, that really what science is saying is that there's two underlying principles in physical reality. One is energy, and the other is fields. Now, energy gives form, gives actuality or activity to everything in the universe. Light has energy, fire has energy, there's chemical energy in chemical bonds, there's electrical energy. But as we've discussed, energy is promiscuous, it can take any form. And the form it takes depends on the fields in which it's bound. So if light's frozen into an electron, it becomes electron energy, vibrations in an electron field. If it's frozen into a proton, it becomes vibrations of proton energy in a proton field. The energy itself could be one or the other. It's undetermined by itself. It's, in a sense, pure potentiality. And in a sense, that takes us back to what I think Aristotle meant when he talked of prime matter, prima materia, which was a kind of potentiality that can take any form. And I think, in a sense, in modern physics, what we call energy, it corresponds rather closely to what he called prime matter. Do you think so yourself?
Yeah, I mean, I was thinking about Aristotle because for him, matter isn't any independently existing stuff, which in a way is another way that people might think about matter today. If you took us away, there would still be matter. Whereas I think for Aristotle, you're right that matter is that which sort of runs through all change. The prima materia is that which means that, I don't know, when I eat my sandwich at lunchtime and the sandwich in one way or another becomes part of me, there's a continuity in that transformation of, as you say, a kind of potential. And the potential just shifts depending upon the circumstance or the form. I mean, the word really is soul. That's how Aristotle understands soul, that it's that which gives shapes, actuality, the opposite of potentiality, to this underlying matter. And so maybe that is much more like the modern conception, and in a way quite counterintuitive. Perhaps another word that came to my mind when you were talking there was how it feels like today a commonsensical assumption would be that matter can be described by quantities. This partly goes back to Descartes and the idea that it's res extensa. It's the thing that has extension, so you can measure it, you can weigh it, and so on. It has quantities. Whereas I think that the idea that actually matter is a kind of quality that then takes tangible form is a way of getting back to the old sense. But also, actually, I mean, you mentioned earth, air, fire, and water, and I think too that when those words were used in the pre-modern world, it wasn't like there was a sort of stuff called fire and a stuff called earth and a stuff called water, out of which everything was somehow composed in various amalgams. But it was much more about qualities, so that fire is that which has the quality of rising, and air is that which has the quality of moving, and earth is that which has the quality of falling, and water is that which has the quality of flowing. And so it was a much more qualitative, maybe experiential way of appreciating nature. People felt themselves to participate in this world of matter and form and soul and dynamism, transience, change, and so on. And perhaps that is what's got lost with this rather sort of this emphasis on quantity and tangible, objective existence, if you like.
Yes, the quantity, I mean, is definitely a feature of it, isn't it? Mass is one of the prime characteristics of matter. And even with energy, you have quantities of energy as well, although it's pure, its potentiality. It can take any form. The amount of energy you use on your electric meter, it measures how much electricity you've used, but it doesn't tell you whether you used it on lots of computers or hair dryers or heating water or whatever, or electric drills. So that also is quantifiable. But it's interesting that the distinction that Aristotle made between matter and form, I think we actually see in the modern world in various forms. The matter of which a molecule is made are the atoms, but the molecule has a form which brings those atoms together in combinations that make it, give them a different well, you could say it emerges, or you could just say it's the form, a higher form that includes the atoms within it. But then the molecule is like the matter out of which a crystal is made. The crystal gives a higher form. And this is a point David Bentley Hart, the philosopher, makes, that in a sense in modern physics, the material cause, what Aristotle called the material cause, that out of which something is made, is then put within a higher level of formal cause, that which gives it form. So the field of the crystal shapes the material cause of the crystal, which is the molecules that are crystallizing, like water molecules crystallizing into ice or into a snowflake, which has a particular form over and above that of the molecules. And of course, we see this just in everyday experience with building blocks. I mean, bricks, for example, to take a literal building block, that you can have a pile of bricks delivered from a builder's merchant, and builders can build houses of completely different shape and plan out of the same building blocks. The bricks are the material cause, as it were, of the house, but the form of the house is given by the architect's plan. It's over and above the bricks, and the bricks are over and above the clay and other minerals in them. They're shaped in a brick factory and given a brick shape, but they have within them crystals and molecules, and those have within them atoms. So there's this whole level of matter and form running up through many levels of complexity.
I think also that it's perhaps worth bearing in mind that quantity has a history as well. I think I'm right in saying that quantity is actually a word coined by Aristotle. And in Plato, there's talk of qualities, but no talk of quantities. And I think what that implies is that to break the world down into units in one way or another requires a certain mentality. It's not automatic or natural, in fact. And I believe, again, that there are some indigenous peoples that, for example, don't really use numbers very much. They perhaps have a number for one or two, but not really much beyond that. And so I find this very fascinating because imaginatively it suggests that there are very different ways of engaging with the world. Now, this isn't just to drop quantity, because clearly it's useful, not least when you have to pay your electricity bill, as you're saying, to know what the quantity is and has been that's used. But nonetheless, when it comes to how we engage with life, if you have quantity, for example, and therefore units, there's a certain arbitrariness, perhaps, to saying there's a difference between that unit and that unit. There's a difference between this person and that person, and between this thing and that thing. And what can get lost when that becomes very reified, as if quantities are somehow naturally written into the order of things, is connection, of course, is dependence, and is, once again, this way of conceiving of life as a process, as a flow, as the potential being actualized, to use the Aristotelian terms again, or indeed, as I think Plato would want us to see it, to understand the world as a kind of manifestation of intelligence, rather than, neutral, even dead, inert building blocks going around bumping into each other. Letting go to some degree of this notion of quantity can precipitate or pivot us into quite a different way of seeing the world. Maybe just trying out almost imaginatively what it's like to think in a world without quantity, to see where that takes you.
I suspect quantity has been pretty intrinsic to human thinking for quite a long time. You know, at least since the growth of civilization, ancient cities had coins. I mean, coinage and currency, and ancient pastoral peoples, like in the Old Testament, Abraham and people, their wealth was reckoned in terms of the quantity of sheep they had, how many sheep were in their flocks, or how many camels they owned. So those were certainly quantitative measures of wealth, and there were also quantitative measures of land. How many, geometric measures of land. In fact, geometry, as the name implies, geometry, is about measuring the earth. It comes from sort of measuring out fields and which bit's mine and which is yours and that kind of thing. So I think those certainly came deeply embedded in civilized human culture. Now, in pre-civilized or non or in hunter-gatherer type societies, I think you're right. There's much less emphasis on quantity, more on
Maybe, yeah, maybe there's a bit of an in-between zone here because I take your point. There are lots of numbers in, like, say, the Old Testament and elsewhere, like you're saying. But I think that numbers themselves were experienced in more qualitative ways before, say, the modern scientific revolution. And the case that comes to mind there is how, for example, I don't know, 40 days and 40 nights didn't, I don't think, literally meant numeral 40 days followed by numeral 40 nights when, say, Jesus is in the wilderness. It means a sort of long period of time. And similarly, I think 3 days and 3 nights means a sort of shorter period of time. And so, a myriad means many, many, many things. It was also the largest number that had a name. 10,000 is a myriad in ancient Greek, but it could be used in a much more diverse sense of ways than just meaning literally 10,000. Sometimes that's worth bearing in mind, I think, when people read the Bible, that it didn't necessarily mean an exact amount that somehow you then got to prove. One of the ways in which actually I think this came up was when Galileo, who I think was seminal in really trying to pin down number and make it mean more explicitly quantity rather than quality. He gave two lectures. I read about this when I was writing my book on Dante and the Divine Comedy, because Galileo gave lectures on the Divine Comedy, can you believe? And the reason is because he was worried that the quantitative notion of number might be taken to be detracting from the qualitative notion of number, which you had in spiritual texts, and so somehow reducing or literalizing spiritual texts. And so he gave a lecture on the size of hell and the size of Mount Purgatory and so on, scale of heaven, in order to show that the quantitative could match the qualitative, and that, as it were, the religious people needn't worry about that. Now, quite whether that was successful or not, because it wasn't so long afterwards that Bishop Ussher, on the basis of the best science of the day, said that the world was made in about 4004 BC, which sort of seems a bit ridiculous now. But I think that, I don't know, I quite like the idea that numbers have a quality. I mean, it would be sort of in sacred geometry, the idea that the number two isn't just two things, but has a quality of two-ness, or three. Three, very important number in Christianity because of the Trinity. But I think if you interpret that number three as meaning there are somehow three parts to one God, you kind of get very confused very quickly. Whereas really what it means is, I think, threeness captures a sense of stability and perfection and completion, in a way that sort of numeral oneness or monadical unity, if you like, just can't really. Because, for example, how can that static oneness have life and movement and the things which you would want to have associated with God? Yeah, so maybe that's just to say, maybe there's a kind of bit of a middle ground here. We've gone off rather on quantity rather than matter, at least I have.
Mm.
But perhaps it's useful because thinking about numbers as having these two aspects, the qualitative aspect as well as the quantitative. Maybe that helps imaginatively move into not just what people felt about matter before, like we were staying with Aristotle, but even what the quantum physics is telling us about matter. As you're saying, this kind of imprisons light, which you kind of get, the E equals mc squared, and there are atom bombs that, exploit that and so on. But how to live that day by day is a challenge, but also maybe a kind of invitation.
Well, I think that there's certain natural quantities which also are like qualities, like the number of planets in the ancient world. They thought there were seven heavenly bodies, hence 7 days of the week. And there were certain numbers where that gives a quality to time, the days of the week. I mean, based on this celestial model. So, and I personally find the best way of appreciating the quality of numbers, at least small numbers, is through flowers. When you look at lilies, they're threefold, and you get 3 and 3 makes 6, and then in wallflowers they're fourfold, the petals, and rose petals are fivefold, and so you get these. You see the quality in these different flower forms. But I think there's also a quality within matter, because if we look at, say, the structure of an atom, the positively charged nucleus, the negatively charged electrons, basically what this is telling us is that electrons and protons attract each other because they have opposite charges. And when an electron is attracted towards a positively charged body, it feels a pull of attraction, and we normally just call it attraction in physics textbooks. But as you know, there's now more and more people are taking seriously the idea of panpsychism, the idea that there's a psyche or mind or potential consciousness, even in electrons, protons, and so forth. Well, how would such a mind experience the world? What would it be like to be an electron? Well, one thing it would be like to be an electron is to be repelled by other electrons and attracted by positively charged bodies, or to join up with other electrons, like in an electric current, as part of a flow pattern. But attraction and repulsion exist right at the very heart of matter, because of protons and electrons and the structure of atomic nuclei and ions and charged plasma. And therefore, one of the most basic emotional patterns that we feel too, attraction and repulsion. We're attracted by some things, repelled by others. That these, which are qualitative experiences, are actually part of matter as we know it. So even in standard physics textbooks, when they talk about electrical attraction and repulsion, they're using words which have a psychological meaning, and are associated with particular feelings. So this isn't something smuggled in to terminology by panpsychist philosophers. It's actually there in standard physics textbooks.
Yeah, I very much like that, and I think that's a way in panpsychism of sort of getting over the slightly awkward way in which an electron is supposed somehow to have a mentality. That feels very hard to imaginatively get into with the best will in the world, even if you're very sort of panpsychically inclined. But to talk about electrons having tendencies or potentials or habits, of course, to use your word, that introduces a certain qualitative aspect to an electron or another subatomic particle, and then, to my mind, helps you talk about panpsychism, which of course is, feels quite linked back to the Aristotelian notions. And I'm at David Bentley Hart, you mentioned. I know he's very keen on this, that the old four causes, not just the material and the efficient, which is what modern science has tended to use, but also the formative that you mentioned there, that which is ensouled in some way, takes on an actual form. And then, of course, also the final, that which towards it tends, that which is its allure or draw, its purpose, even. Bringing that element back in from Aristotle. Who knows? I mean, there might be a great return. Aristotle tends to get rather mocked and sneered at. But even without, of course, modern science, maybe he was nonetheless onto something really very profound.
Well, actually, I think we can already see it again in modern physics. It's hiding in plain sight. A final cause within matter, because gravitational attraction is a kind of final cause. It works by attraction. When a meteorite is pulled towards the Earth, it's attracted towards the Earth. When anything drops, it's attracted towards the Earth. It's an attractive force. I know that Einstein modeled it geometrically, but in practice it's an attractive force. And what would happen if there's enough matter in the universe and if the universal expansion drew to a halt, is that the attractive force of all the matter attracting all the other matter would cause everything in the universe to come together into an ultimate black hole and of a final unity. So there's a sense in which matter through gravitation is acting as a final purpose, a goal for other matter by attracting it. So even there, again in modern physics, and again with the use of the word attraction, we're dealing with something that's a pulling force, not a pushing force. But there's two other aspects of matter I think we should touch on. One is the mythological aspect of matter. And the word matter itself, of course, has the same root as the word mater, mother, and the material out of which something is made. And then that, of course, in the philosophy of materialism, says that there's nothing but unconscious matter in the universe, or physicalism, which says there's nothing but unconscious physical processes, basically equivalent to materialism. Materialism is the basis of the most common form of atheism, that the whole universe is made of unconscious matter. There's no God out there. There's no consciousness out there. There's just consciousness for an unknown reason inside our brains, and maybe in animal brains as well, that has a very, very restricted view of consciousness, which can't be explained in terms of a fully material universe. That's a problem with materialism. But I think what's less noticed is that materialism has a kind of unconscious mythology, that what it started historically as a rebellion against an extreme form of mechanistic Protestantism. God is the supreme engineer and creator of the whole universe. God is the all-powerful emperor who sets the laws of nature. God is the engineer who designed the machinery of nature, and nature as a machine, and then presses the start button. So it's very much a kind of male God that atheist materialists were rebelling against in the 17th, 18th, and 19th century. And what they said was, no, there's no God out there. The total reality is matter. Matter is the sum total of all things. Basically, it's saying that we don't believe in the Great Father. We believe in the Great Mother. So matter is, I think, a kind of unconscious cult of the Great Goddess, the Mother principle. So it's just all from the Mother and not all from the Father. Of course, as soon as you put it in those terms, it's obvious this is an unbalanced metaphor in both directions. If you're going to use mother and father as metaphorical terms, in a sense, they're co-determinative. You can't have a father without a mother, and you can't have a mother without a father. They're polar. They're part of a greater unity of which they're polar parts. But I think that materialism, when one sees it as the unconscious cult of the Great Mother, everything comes from matter, everything goes back to matter, matter is the source of all things. So it is basically a Great Mother cult, I think. So hard-nosed materialists who think they're just being rationalists, I think are unconsciously, and the fact it's unconscious doesn't mean it's not powerful, it means it's so powerful that it's kind of repressed the power, the emotional power of this.
That's a splendid example of what I sometimes think of as a Rupert Sheldrake surprise. And we've been speaking a lot, and I've never thought of materialism in that way. But I guess it's even in the name, materialism, martyrism.
Yes.
Now, look, I mean, you might be offending a number of people, though, making that kind of link, because normally, when people refer to the need for a mother goddess, it's as a corrective to present day assumptions about a mechanical universe. the need for something that's felt, that's nurturing, that's imminent, and so on, rather than abstract and dead and objective. I just, my first thought when you were saying that was, I wonder, how that sits with the idea that actually we're already in a kind of unconscious age of a mother goddess.
Well, I think what makes it even more so is that the final point I wanted to raise is dark matter, that the universe doesn't behave as it ought to according to the laws of gravitation. Galaxies and attract each other too much. The orbits of stars in galaxies don't behave as they ought to according to gravitational principles, which is why physicists have invented huge amounts of unobserved dark matter to explain what's going on in the universe. So talking of unconscious forces, it's as if physics has recognized the cosmic unconscious. Dark matter, we haven't a clue what it is, or whether it even exists. I mean, many physicists would say there's other ways of explaining these things. You don't need to invoke dark matter, but the mainstream at present invokes dark matter. So not only have you got an unconscious cult of the Great Mother, you've got an unconscious cult of the Great Mother, of which something like 4/5 is unconscious and unknown. That's actually the state of play of materialism if we take it seriously as a belief system.
I wonder whether we're close to a bit of a tipping point on that front too. Just in recent weeks, there's been two or three stories in the press about dark matter and dark energy, suggesting, broadly speaking, I mean, I've no doubt the science is very complex because this is all argued out in abstract equations, but broadly suggesting that maybe something closer to what you've argued, that that matter and forces and energy and so on aren't fixed as if they are unconscious, but have habit, have the possibility of change. I mean, I touch this because my physics tutor, Carlos Frank, has long worked on dark matter and dark energy, and he's one of the voices that have recently been suggesting things perhaps aren't as they have seemed, even to the extent of challenging assumptions like uniformitarianism, the idea that things have been the same always and everywhere, and that notions such as potentiality may start to be invoked much more to explain what's observed with the way that galaxies form and hold together and the movement of visible light, visible matter in light across the heavens.
Well, I think it all goes to show that matter is much, much more mysterious than we normally think, and there's much more to it than we normally think. And it's, an open question, really, as to how our understanding of matter will change as time goes on. And partly because of these cosmological questions about dark matter and dark energy, partly because of panpsychism and what it would mean to take seriously consciousness throughout the universe. And partly, I suppose, the origin story through the Big Bang is always questionable. I mean, right now we have the idea that matter and radiation were decoupled about 400,000 years after the Big Bang. There was the decoupling of matter and radiation. Before that, there was a kind of opaque fog of particles, and light couldn't move very far. And when the two were separated very near the beginning of the whole universe, we have the separation of light and matter from each other. And it's actually not unlike the book of Genesis, chapter 1, verse 4, where God says, "Let there be light." It's the first act of creation, apart from the Spirit of God moving over the face of the deep, creating waves, no doubt, as like a wind over the water. So the first actual definable thing is light. And then it goes on to say, and then God created light and then separated the light and the darkness. So it's very like in the modern cosmogony, the creation story of the Big Bang, this decoupling of matter and radiation from each other. And of course, modern physics is a great deal to do with the relation of matter and radiation, and coming back to the starting point that matter, as David Bohm said, can be seen as frozen light, that radiation can turn into matter, and matter can turn into radiation because they both contain energy. but within matter, the energy is bound in particular forms, and therefore it's located in particular places and interacts from that place with other matter through gravitation. So there's still so much we don't know. But anyway, I'm very glad we've had this chance to discuss it, Mark. Thank
Yeah,
you.
look, as before, the minute you press at something that's seemingly obvious, the far less obvious starts to show up. So thanks very much indeed for guiding us through some of these thoughts.